Okay, synthetic substitution and division is the game today. This will be my fourth try to make this video, so let's get it right this time. I'm going to first show plain old evaluation, just plugging a 4 in for x. So here's my function, f of x equals all this stuff. And I want to just plug in a 4 and see what I get out. Well, you know that if I plug 4 in for all my x's, and I square first, so 16 times 3 is 48, minus 8 minus 1 becomes a 39. So f of 4 is 39. And that's one way to handle this problem, just plug in the 4 and see what happens. Another way, though, is called synthetic substitution. Now, synthetic substitution and synthetic division are basically the same thing, and I'll explain kind of how they're similar and different in a moment. But to do synthetic substitution, I'm plugging a 4 in for x, so I put that 4 in this little corner here, in that top left corner. The coefficients with their signs get written out in this row next to it. I'll draw a line down here. And this is how you set up synthetic substitution. Now in green, I'll show the steps I'm going to do. The first thing you do is you just drop down this 3. Then I'm going to do 4 times 3. And that answer is 12, and I'm going to put that here. So I copy a 12 over here. Oops, that should have been purple. I copy a 12 over here. I'm now going to add negative 2 and 12 to get 10. So I'll again do 4 times 10, and that's going to go up here to become 40. I add one more time, negative 1 plus 40, and that's 39. And the number that it spits out at the end is how it evaluates. This means that f of 4 is 39. Now, right now you're thinking, well, okay, sure, that's cool and all, but isn't this process over here way easier and simpler, and there's none of this weird adding stuff over here? Why would we bother doing this? And let me see if I can convince you of why this is really worthwhile. Here's a slightly longer expression or equation, y equals 2x to the third plus 5x squared minus 28x minus 15. I'm going to find f of 3. And I'll do it by the synthetic process. So I'm going to put a 3 up here in the corner. I have 2, 5, negative 28, and negative 15. Well, first I drop down the 2 and write this here. 3 times 2 is 6. 6 goes there. I'm always adding. 5 plus 6 is 11. 3 times 11 is 33. I'm adding. Negative 28 plus 33 is 5. 3 times 5 is 15. Negative 15 plus 15 is 0. This means that f of 3 spits out a 0. Well, if you think about that in terms of its graph, this is a cubic polynomial, so it's going to have probably 2 terms in it with some x-intercepts and a y-intercept, and 3 is one of those x-intercepts. X equals 3 is a root of this equation. Because I plug in a 3, I get out a 0, it's the 0.30. Well, if x equals 3 is a root of the equation, then we know that x minus 3 is a factor of the equation. I can take this, and if I try and factor it, one of the bubbles will be x minus 3. Well, then the question becomes, what's all the other stuff it would multiply by? What other 3 terms can I factor this out of? And that's where the magic happens. This is the other stuff. 2x squared plus 11x plus 5. Since I plugged in a 3 for x and I got out a 0, that means x minus 3 is a factor of this expression. But the beauty of the synthetic process is these leftover numbers become the coefficients of the remainder. The coefficients of, I shouldn't use the term remainder, the coefficients of what's left when you factor out the x minus 3. So really, this factoring process was done very quickly when I evaluated. And now I can do it again. I can say, okay, I'm going to take this term, or this expression, 2, 11, 5, and I know from, advance, having set up this problem, that negative 5 is also a root. If I plug in negative 5, I'll get out 0. Drop down to 2, multiply, add, multiply, add. I got a 0. That means that at negative 5, I'll have a 0. So x equals negative 5 is a root. So x plus 5 is a factor. Well, I already had a factor of x minus 3. I now have a factor of x plus 5. And I know what's left is going to be this stuff. So by synthetically evaluating roots, I can factor. Now the game becomes, okay, well, how do you know that negative 5 and 3 are roots? Isn't that the whole point? If you know that, why do you have to evaluate? And we'll talk about that later, how to find those numbers. But I wanted to show how synthetic evaluation is really just factoring. And if you think about it, factoring is really just division. So that's why I say synthetic division is basically the same as synthetic substitution, because you're basically checking to see if this is a factor of this. So like if I were to do the long division, which I won't finish, but if I do this division, and after I do all my stuff and I drop down my things and everything comes out and I get a 0 down here, if there's no remainder, that means that this was a factor. If there is a remainder, then it wasn't a factor, and that's okay. But I can kind of think of division as me checking to see if something's a factor. So here's the one key difference between synthetic division and synthetic substitution. Since I'm dividing by x minus 6, I put a positive 6 here in the box. So I'm basically saying I think 6 is a root. I check what makes this bubble equal 0. Oh, well, 6 is what makes that bubble equal 0. So if I'm dividing by x minus 6, I put a 6 here in the corner. I have 2, negative 9, 0, and negative 4. Why did I put a 0 there? Because there's no x to the first term, and I have to have a placeholder for that, just like in long division. So I go x to the third, x to the second, x to the first, and that's basically x to the 0. So let's go through this real quick. Drop down the 2, 12, add them up, get a 3, 18, add them up, get an 18. 18 times 6 is 60 plus 48, so 108. Negative 4 plus 108 is 104. This is my remainder. Since it wasn't a 0, that means that x minus 6 isn't a factor of 2x to the third minus 9x squared minus 4. But it does mean that I can find the quotient. If I do this divided by this, I'm going to get 2x squared plus 3x plus 18 plus 104 over x minus 6. That is synthetic division. The exact same as synthetic substitution, only you have to take whatever you're dividing by and put in the box whatever makes the thing you're dividing by equal 0. So, I want to pause and ask any questions right now, but you can't actually ask me any questions. Of course, you can always send me a message or leave a comment in the YouTube video or whatever. But let me do another one over here. I want to see what makes this equal 0. It's negative 3 over 2. Subtract the 3 and divide by 2. So up in the corner, I'll put negative 3 over 2. And I actually don't know how well this is going to work out. I think it'll work out pretty well, but not perfectly. 2, 4, 8, 10. There's supposed to be a plus in there that's not showing up right now. Drop down to 2. 2 times negative 3 halves is negative 3. I add those up. 4 minus 3 is 1. 2 times negative 3 halves is negative 1.5. You can think of it negative 3 over 2 as negative 1.5 if you want. Add those up, get 6.5. 6.5 times negative 3 over 2 is something. I wish I'd left that a fraction. 6.5 times negative 3 over 2, what I'm going to do, 6.5 is really 13 over 2 times negative 3 over 2, so it's negative 39 over 4. I add those up, so it's going to be 40 over 4 minus 39 over 4, and wow, it's a quarter. Not bad. So this ends up being 2x squared plus 1x plus 6.5 and 1 over 4 over 2x plus 3, which I would simplify to be, I multiply the 4 and the 2x plus 3, so that's really 1 over 8x plus 12. People often have questions of, how do you know what power to start with? Since this biggest power was a 3, since the degree was a 3, this just drops down by 1 to 2x squared. So had this been like 2x to the 7th, this would have been a 6th down there. The thing about synthetic substitution is it only works if you're dividing by something of the first degree, something where the power is 1. If the power isn't 1, you can't do it at all. That's why we still teach you long division. Had this been 2x squared plus 3, you can't do it synthetically. It can only be done by long division. So to recap, synthetic substitution and synthetic division are essentially the same thing, where you do division through this process. What you're left with becomes the coefficients of your answer. And I think that's good for today. Thank you.